My name is Kelly Paffel, Technical Manager for Invino Engineering LLC, located in Tampa, Florida. We're a domestic and international engineering firm looking specifically at steam systems. Today I want to talk about steam system optimization, types of steam, and terminology. And today I want to look at two specific terms, saturated and superheated steam. This is part one of several parts of a series regarding steam. Utility steam. Utility steam is sometimes called live steam, plant steam, essential steam, generator steam. But it really means utility steam, no matter what type of boiler we have to generate the steam. The international accepted terminology is utility steam. Utility steam can be saturated or superheated steam depending on the process applications and how we are generating the steam. Steam produced from steam generating sources such as fire tube boilers, water tube boilers, HRSGs, HRSGs, heat recovery steam generators, reboiler, etc. So there's a multitude of ways that we can generate utility steam. But at the end of the day, it's utility steam which can be into saturated or superheated conditions. Now, the water source that we use for the boilers can be water softeners, reverse osmosis, other means for water preparation. But remember one thing, utility steam is pure. No chemicals or minerals will be carried out of the boiler by the steam. And sometimes we use a corrosion inhibitor. Amine can be injected in the steam line to assist in preventing corrosion in the steam system. So we get into types of steam and terminology. First one I want to talk about is saturated steam. Saturated steam is dry and visible fluid. Saturated steam is not wet steam. Wet steam is steam quality, which we'll be talking about that in part 2. Saturated steam means saturated with energy, contains both sensible and latent energy. So remember, saturated steam is a dry and visible gas. So as you can see right here, when the steam is discharging to atmosphere, that right here, it's invisible. You really cannot see it. So remember, saturated steam is a dry, invisible gas. You cannot see it. Contains both sensible and latent energy. Saturated with energy, not wet. Now, 98% of industrial processes will only use the latent energy of the saturated steam. Remember, there's two energies in steam, latent energy and sensible energy. So when the steam comes into the heat transfer from here into here, the latent energy is given up, condenses down to condensate, and the condensate is removed as quickly as it's formed to get the maximum efficiency out of the heat transfer. Sensible energy will be in the condensate and return to the boiler plant for recovery. Remember one thing, 16% of your energy sits in the condensate, so we want to make sure that we recover it. Now, latent and sensible energy of saturated steam content will depend on steam pressures and temperature. Higher pressure, higher temperature, or less usable energy. People always say, I want higher pressure, more usable energy. You have less usable energy. Remember I said processes use latent energy. At 5 psig, the latent is 960.5 BTU per pound. At 200 psi, the latent energy is 837.7 BTU per pound. So as you go up in pressure, you reduce the amount of usable energy. But the thing about it is when I go up in pressure, I get temperature. And really what the process is looking at, the temperature I need to make the process work. Saturated steam occurs when both liquid and gas phases are present at the same temperature and pressure. Many advantages, even heating throughout the heat transfer. Probably number one, ability to control temperature through the pressure, so I can control pressure to process and also control temperature. High heat transfer coefficient, C. In particular, high coefficiency is why heat transfer primarily uses saturated steam instead of superheated steam. The next one is superheated steam. So we produce superheated steam. We take the saturated steam, which is off of this drum here, and we put it through this bank of coils or tubes inside the boiler here, give it more sensible energy, increase the temperature of the steam without increasing the pressure. Remember, increase the temperature of the steam without increasing pressure. Superheated steam, higher temperature, lower density than saturated steam at the same pressure. Why use superheat? One thing does not occur in superheat conditions is phase change or condensation. So as I'm going through multiple stages in a high pressure turbine here, that I do not want condensation to occur. Condensation will have erosion effect onto the nozzles and the blades inside the turbine. So therefore, I do not want condensation to occur. So the applications, turbines, subblowers, and a few high temperature processes. So one of the things that we use superheated steam besides turbines is subblowers for the boilers. So a subblower system is a tube here injects steam inside or in the boiler between the two banks and blows soot off of the boilers. Quite commonly used on boilers that burn coal, wood, or black liquor, or some off-fuel that we have to get rid of the soot buildup under the tubes. So that's another application that we use superheated steam. The disadvantages of superheat, because we talked about all the advantages, that condensation will not occur. The disadvantage has a low heat transfer coefficient. Variable steam temperatures at constant pressure. So the temperature can vary. It's not a direct relationship to the pressure. More expensive components due to the high temperatures. As we go up in superheat temperatures, of course, the materials will change due to the temperature. The vast amount of latent energy cannot be released until the steam achieves saturated conditions. So when we take superheat and send it out into the plant operation, where we want to consume the thermal energy of steam, here, is that we'll add these superheaters in the system, bringing the steam back to saturated conditions. Thus, when we go into heat transfer surfaces, the latent energy will be released. So that kind of concludes part one, and there'll be several other parts to this because we're going to talk about steam quality, flash steam, pure steam, clean steam, the other terminologies that we use in steam. Remember, we are your partners in steam systems. We can assist in steam system assessment, steam balancing, steam system performance, engineering, steam engineering, design, and long-term impacts, upgrades, process changes, improve reliability. Of course, number one in any steam system is safety of the system. So you need any help or information, please contact us at this email addresses below, and have a great day. Thank you.